Let's look at solving a typical problem using the definition of molarity. What is the molarity of an electrolyte solution prepared by dissolving 4.5 grams of potassium chloride in water, giving a total volume of 45 milliliters? So if we look at our definition of molarity, which is what we're solving for, we need moles of solute and liters of solution. We're actually not given either. But we can determine moles from mass by dividing by molar mass, and we can convert from milliliters to liters. So to calculate our molar mass, we look at the periodic table. For the sake of convenience, we'll round our molar masses to the 100th place. So the molar mass of potassium is 39.10 grams per mole, and the molar mass of chlorine is 35.45 grams per mole. Since there's one potassium and one chlorine in the formula, we merely sum 39.10 grams per mole plus 35.45 grams per mole to get a molar mass of potassium chloride equal to 74.55 grams per mole. So to calculate moles from mass, we take our mass, which is 4.5 grams of potassium chloride, and multiply it by the conversion factor, 1 mole of potassium chloride per 74.55 grams of potassium chloride. Our grams go in the denominator because that's what we want to cancel out. And since I'm given 2 sig figs, I round my answer to 3 sig figs, 0.0604 moles of KCl. I don't want to round to 2 sig figs. If you round too early on, then your answer may not be correct. So now we have our moles of our solute. Now let's look at getting liters of our solution. We're told we have 45 milliliters of solution, so we multiply by the conversion factor, 1 liter per 1,000 milliliters. We can also just move our decimal point 3 places to the left, which is the same as dividing it by 1,000. Either way, our volume of solution in liters is 0.045 liters. So to calculate molarity, we divide our moles of our solute by our liters of solution. So 0.0604 divided by 0.045, and then I get this long answer with a repeating 2. Since my original mass and my original volume only had 2 sig figs, I'm going to round my molarity to 2 sig figs. So I'm going to express this as 1.3 capital M, which means molar of KCl. Now, we can express molarity as this capital M, and we can also write moles of KCl per liter. So those are the 2 ways we can express molarity. So we look at the answer in the textbook. We see they get the same answer. They go about their conversions in a slightly different way, but we end up with the same answer.